Hey, Professor.
Yo.
I need to give you like a mild disclaimer next week. So Apple, okay, so I told Apple that I had like a final round interview on Monday with another company, and now they're like scrambling.
You're on webcam for what it's worth.
Oh yeah. Well, that would have been nice to know. So basically, they're trying to figure out when to bring me on site for a final round interview with them. And so one of the days they asked me was March 12th, which is the day of our interview.
Okay.
And so what I'm thinking about is I'm trying to get them to do it March 13th. But I just wanted to let you. Yeah, right. I know. But I wanted to let you know that if they can't make that work, though, would there be any way maybe for me to take the midterm early, or not even?
Early sounds hard because early means I have to have the midterm written.
What about on Friday or?
Keep in touch and let us know.
I'll let you know as soon as I know.
It's not great.
Yeah, it's not a great workout. I mean, they said they'll try to make the 13th work. But if you're not okay with me taking the midterm any other day, assuming that the worst comes to worst, then I can always just
try hard to make another day work.
I will.
And
I mean, I am trying.
if that doesn't work out,
why is the floor sticky?
Try not to lick it.
Yeah, for real. Anyway,
Good luck.
I'll keep you informed.
Cool.
So, I guess Apple's just trying to get me on Monday. You can't make Monday work.
Okay, I can see that. So like, you
Yeah,
finish
I
that,
like-
now you
I have
have
midterm.
NT
Do
elements.
the 13th.
And you know what they're right? And those pieces for sure have to cover the remaining elements. So do you know that?
Do you really want to work for a company that wouldn't schedule an agenda?
You're on webcam, aren't you?
I am.
You really want to bad talk Apple on webcam?
Sure.
I guess you don't care, right? You,
Kind of got my own thing going.
If all of them were like the same.
We could go viral.
You're saying like within the remaining
I want to work for a company
elements.
that I can work.
Because your rate elements still could use all like that case that is on. So if you had your option to average would still be NT.
Like, I'm sure that
Each
might
set
go in
would have NT.
like, I'm pretty sure if you got that good job, you went in and did a better job.
Because when you do your set, you don't necessarily right? You know that you're-
But I mean, you would pay off. Because you'd be like, next to it.
So you know that the element is average of the
Black profits.
and I know that
You know, like how they were like, we're such, like, the same battle last week. Is that line of like, the second writer, it's like, oh, it's okay.
so we just all the stuff that is inside NT. There can be well, there can be.
I gave you guys copies of this history.
Right, to like make up for that. So no matter what, you have all NT related or
It's not that
Sorry.
You might have noticed this before. You guys want to the what?
Good morning, everybody. How you doing? fewer and fewer of you by the day. Think everybody will show up for the midterm? It'll be very exciting to find out. All right, we're going to start, why not, with the UI of the day. Maybe. Go. You have to imagine your own like bass rich track to this one because it's silent. So everybody get the idea of what they're doing here. They have like large displays that they want to do touch interactions on. And so they're enabling that by using the camera and touch on the phone. Is it good? All right, you get the gist of this. If you were to design an experiment to test how well this would work, what sort of like variables would you be thinking about? What would be your conditions? What would you compare against? Yeah.
You use Fitts law, moving an object into a space.
Yeah, so that would be interesting. You could do a like classic Fitts law sort of experiment in terms of like doing drag and drop from place A to place B. All right, let's go with that experiment. So if you did that, what would be your kind of independent and dependent variables in that space? What would you measure? Yep.
Well, as one independent variable, you should have the distance that it's there from the screen.
Okay, so you could test, does it matter how far away from the screen you stand? Agreed? Yep.
The time it takes to move from point A to point B.
Okay, so you can measure the time. That would be a reasonable dependent variable. Yep.
Size of the displays you're working with.
Okay, so would you want to test those, or would you want to control those, or would you want to randomize those, or what would you do there?
We could probably control those and then test for how efficient or how fast the person is able to switch from one display to the other.
Okay, so maybe you would control those across conditions, but then test something else. Yep.
I would compare it like against the mouse for like A/B testing.
Okay, so A/B testing against like a mouse might be interesting. Given what you know about like input devices, what would you expect to win there in the like this thing versus a mouse? You would expect the mouse to crush it. Yep.
I think I'm interested in how long people have to hold up their phone.
Yeah, there's some ergonomic concerns there, right? Like if you had extended interactions with one of these things, could the person like hold up their phone indefinitely? And that's kind of true of all like AR applications, right? There's this ergonomic concern around augmented reality of like, can people realistically like hold things up, or are we moving to a place where that's only plausible with like smart glasses?
How much of this is using their smartphone, like how much they use it today?
Yeah, okay, so if, so phone use or phone familiarity as a variable, how would you deal with that?
Either randomize it if you were going for a general population, or at least report it so you can see if it matched up to like how good it's.
Yeah, so you'd probably either randomize it or like counterbalance it and try to make that all even out. Makes sense. All right, so today we are digging in into like details of data analysis at what we are admitting is a very light level. So this is in no way like a stats class, and I am in no way a stats professor. But what we're going to do today is just kind of scratch the surface of statistics in terms of kind of the depth that I expect any like UX professional to be at least fluent in for when you go out for like a job interview or when you're talking to somebody, you know, else in the field. So as an example, we're going to go back to the bubble cursor that we talked about on Tuesday. So if you recall, it's this basic experiment where you have a cursor that grows in size such that it is always selecting exactly one target on the screen. And we're going to kind of walk through the implications of designing an experiment around this thing and what the data processing might look like. Okay, so you have this experiment going where you have, like, imagine we had 1,000 people go online and use this thing and try to select the red target, okay? And they did it either with the bubble cursor or with a regular mouse cursor. And so they went and they had to pick the red targets as the red targets moved around. What would your data look like? What sort of data might you have from that experiment? Yeah.
Similar to what's up there, the number of hits versus misses.
Yeah, so what you're going to end up with is some sort of stream of events, basically. So in this table, we have like a user ID, the type of cursor they were using, like normal versus bubble. You have, I think that's the size of the target, so how many pixels wide the target is, how many errors they've made cumulatively in the session, what trial number it is within the session, and then a timestamp, so that you can find like time deltas between the different events. And given this information, so we don't know yet whether we have like a between or within subjects design, we just have this like stream of data. What's the first thing that you would do with it as a like wannabe statistician? Yeah.
Plot it.
What's that?
Plot it.
Okay, you can plot it. That would be one thing to do. We'll get to that in a minute. Yep.
Before plotting it, you want to clean it up. Maybe I see that we have the comments. You can use the delimiters to kind of put things in a table.
Okay, so there's some cleaning we could do. Let's say we've got the clean data, but we're not ready to plot yet. What might come in between those two things? Yeah.
Some sort of like average or standard deviation.
Yeah, so just like start counting some stuff, right? So this is the world of descriptive statistics, where you just kind of take the data that you have and you say what truths there are that exist in that data. So if we have like, you know, we count the total number of trials. We had 5,680 trials, half of them in the normal condition, half of them in the bubble condition. And we can take those timestamps and we can say, all right, the average time it took to select a target using the normal cursor was 976 milliseconds. And on average during the session with the normal cursor, there were 2.5 errors. And with the bubble cursor, it was 800 milliseconds and there were 0.287 errors on average. If that was our data, what conclusions might we start to draw from that? Given that we're not being robust here, what's your high-level conclusion here? Yeah.
It's quicker using your bubble, and you also have less number of errors.
Okay, so this looks good, right? Like at a high-level first pass, this looks promising for our hypotheses. If you remember our hypotheses last Tuesday, they were that it's going to be faster with the bubble cursor and there's going to be fewer errors with the bubble cursor. So far, it looks good. Now that we have like a glimmer of hope, we want to start like formalizing that notion. And so there's other things that we could be counting here. Sorry for the tiny text, but this was talking about just the like normal cursor versus the bubble cursor. But actually we have more conditions than that. We had this sort of 2x2 design where in fact we have people completing the smaller targets with the normal cursor and the larger targets with the normal cursor, and the smaller targets with the bubble and the larger targets with the bubble. And here we have a little bit more detailed, you know, statistics, just looking at those combinations of target size and cursor type. And so here you could start to pretend at least to draw some conclusions about any interaction effects between these things. And you could start to say, all right, well, like, is there a differential effect? You know, does it matter whether the targets are large or small based on how these things, on how the cursors perform? And so we'll get into that in a minute. For your like central descriptive statistics, the things that describe the main features of the collective data, you have things like central tendency, so mean, median, mode, your classic like high school stats. You have dispersion statistics, so range from the biggest to the smallest, standard deviations, things like that. You can start to talk about the shape of the distribution, bearing in mind that you're only talking about the distribution of the sample, not the distribution of the underlying population. And then you can get into frequency distributions. And so we'll explore a little bit of each of those coming up here, including like how you start to get towards inferential statistics from these descriptive statistics. So getting back to this notion of you've got a bunch of data and you want to kind of start pulling some conclusions out of it. Your notion initially was right, that like what people really do at this point is not start taking means and medians and modes necessarily. It's like throw it all into some package that'll graph it for me and see if anything interesting comes out of it. So just to kind of play around with the data, look at it from different perspectives, put it in a histogram, put it in a scatter plot, all these different things. And so there are tools out there that do this really well. In this lecture, we're using just like a bunch of graphs that like are spit out, I think. But you could also do this with, you know, Tableau or some other like big data visualization package. Lots of ways to kind of play with your data and see what makes sense. So here's our first graph. Based on just looking at this thing, can anybody tell me what this is? Admitting that it's bad purposefully. What do you think it is? So we have one axis. This is movement time, but of what? So this is just like all our data, and it's just the deltas on time between clicking on different targets. So this is all 4 conditions crammed onto one scatter plot, and with vertical jitter. So there's just like random noise on the vertical axis so that it's not all plotted on the same line, right? So it's a 1D scatter plot with jitter. Very straightforward to build. More useful might be actually coloring the conditions. So here we have our 4 conditions. This is the normal cursor with the smaller targets, bigger targets, bubble small, bubble big. And here you can start to at least get a little bit of sense for like what's going on with the different cursor types. So like the bubble cursor seems to be pretty consistently further to the left, and the longer times are coming out of especially the like small targets with the normal cursor. And so now you're starting to like build some proof for your hypothesis. That's useful. We could clean this crap up so that we can actually see a little bit more what's going on. So just taking the horizontal jitter and compressing it by condition looks like that. And suddenly this is starting to look like more plausible for how we get some answers. Yep.
What is the vertical axis?
Nothing. It's just space.
So to make them not sit on top of each other.
Correct.
Stacked.
Yeah, so it's called jitter when you just like put something that doesn't mean anything on one of the axes to spread it out a bit. Yep.
So put that yellow one far.
Yeah, what's up with that guy? What would you guess is going on there? That guy, the one with the big circle around him? Yeah. Somebody wasn't sure what to do, or more likely somebody like started the experiment and then just like alt-tabbed over to like some cats or something. And then we got this like crazy 5 minutes, whatever that is, a long time of, I guess it's just 12 seconds. 12 seconds of, no movement there, which is probably the max. So what is that data point? What do we call that data point? It's an outlier, and we don't like it. Real statisticians have like various ways to deal with outliers and various models, and we can treat outliers in this way. we're not real statisticians, so we usually just say, screw that, that doesn't make any sense, and throw it away. So that is what it is. And if we did that, then suddenly this plot would be much wider, and we would be much happier, and everybody would be able to see our data much better. Oh, look, the slide says don't do what I just told you to do. Oops. Don't discard data just because it doesn't fit your expectation. Maybe your assumptions were wrong. No, that's true. So look at it and say, like, does this make sense? Is there a plausible way that you could have gotten this result genuinely? But if it doesn't seem genuine, screw it. Like, throw it away. Especially in these online experiments where you're not like watching over the person's shoulder, it really does usually make sense to throw away the extreme outliers, just because they're almost certainly somebody that just wasn't following protocol, like didn't play by the rules. And so the like rule of thumb in human subjects research is usually that if you have an outlier that's more than 3 standard deviations from the mean, you just pitch it. You assume that it was garbage data. You try to explain outliers that are within that like 3 standard deviation window, but if they're beyond that, screw it. All right, what's this thing? It's a histogram, which mostly shows up in showing you people what your like midterm scores are and things like that. It's like the classic use of histograms. So how do you go from data to histogram? What's the process there? What's that? Frequency of occurrence, but we have a continuous variable, right? We have time.
So quantize it and then
Yeah.
frequency.
Yeah, so you have to bin it in some way. And so you come up with some quantiles of data, and then you bin them into those, and then you draw the frequency distribution. So it's just a graphical representation of the distribution of data. It's starting to get towards an estimate of the kind of distribution of the underlying population. So this is where we start drifting away from like descriptive statistics and into inferential statistics, is as we start guessing, like, does this really fit the underlying population? So anyway, you can do lots of different types of histograms. This histogram is useless for the same reasons that the first scatter plot was useless, in that we've kind of bunched all of our data into one place. There's lots of ways you can deal with that. You could stack bars in the histograms. That's pretty popular. You also could just stack your histograms. So here's the histograms of bend movement time per condition. And again, we're starting to draw closer to confidence in the truth of our hypothesis, as we see that really the distributions are pretty similar between people, which is good. That's what we would expect. And it's better in our bubble cursor conditions. What sort of distribution are we starting to head towards here as we start looking at these histograms? It looks like something we've talked about. Yeah. What's that? I don't think it's normal, actually. I think it's one of these power law looking things, which we would expect. We would expect this to be a kind of long tail power law thing. This one, most obviously, there may be something about the bubble cursor that makes the bubble cursor's distribution more normal than more power law-y. And that would make some sense, because Fitts law is very power law-ish, and we're kind of ripping Fitts law out of the equation when we do the bubble cursor. So it makes sense that that moves into a kind of less human-looking distribution. Other types of displays. Here's a crazy error count for trials graph. So what is this trying to tell me? Oh, this is just the scatter plot. So this is a scatter plot of how many errors you made per condition. And again, strong evidence here for our bubble cursor being superior in terms of error prevention, as the normal cursors are all blown up over here. And just this one schmuck who didn't do what we wanted him to do on the bubble cursor condition is screwing our data. Yep.
How do we factor error in the amount of time it takes to go from one point to the other?
So which part of that?
So suppose I click on one bubble,
Uh-huh.
go somewhere else,
Yep.
and I'm clicking on right bubble,
Right.
and then go to the second.
I
Is it the
assume-
sum of the two, or
I assume it's the sum of the two. That would be my guess.
but would that play well with our test to find out how much time it takes to go from point A to point B?
Yeah, it's
So
interesting.
Imagine if you go from point A to point B,
Mhm.
and you on your point B, and then coming to point B is going to take less amount of time than going to
Right.
point C at the bottom and then going to point B.
Yeah, it's a good question. It could be that it's just between clicks that wouldn't shock me, but then you would have to really control for like weird things where somebody was just like everywhere. It's interesting, like in the bubble cursor case, there's no such thing as selecting nothing. Whereas in the normal cursor case, you could be just like clicking out in error somewhere. And so how do you control for that? And how do you design your experiment around that? I'm going to guess they just sum those 2 times. That's what I would do. But then you're right that it adds this complicating factor where you have some interaction between errors and time that may not have been expected. All right, here are the histograms for errors. So same sort of deal, like here you can see, like this is just sort of the sideways histogram. But you do have this like nasty long tail over here on the normal cursors, where like some people went way too fast probably and had like super high error rates on the normal cursors, whereas on the bubble cursor rate, it seems to be a little bit more steady, except again for that guy. All right, a little note on median versus mean. For normally distributed data, of course, median and mean are the same thing. Most of the data that we gather in human subjects trials is pretty heavily skewed. It's kind of, a power law sort of distribution, either to the left or to the right. And it's even worse for uncontrolled online experiments where people are just playing around on the computer and they pay attention some and they don't pay attention some, and you get lots of outliers. And so the presence of like weird outliers on one side or the other does more bad things to a mean than it does to a median. And for that reason, most human subjects you work in terms of medians instead of means. So at least for purposes of this class, assume that I almost always care more about the median than I do about the mean of a set of data. So just a couple of examples of that. Here is a skew to the left and here's a skew to the right. And you can see that the mode is at the peak of the curve, of course, and the mean gets pulled off by the skew, but the median stays closer to the mode. And here, the median is probably closer to the truth because most likely this stuff out here was experimental error, not like real data error, or like real data differences, I should say. They both have value. Often you'll report both. We'll show a few different ways to do that, but if you have to choose one, choose median. And then, this is the power law sort of deal where we have the mean getting pulled over by the people who are like amazing, and the median just kind of hangs out in the middle. So this is a graph of contributors of photos to some competition. You note that these power laws keep coming up. And so this is a number of edits to Wikipedia per person sort of graph. And the top contributors are like completely insane. Like the top contributors are doing like hundreds of thousands to millions of edits, usually very small, but hundreds of thousands to millions. But if you're trying to write up a study of like how Wikipedia editors operate, and like your target population is Wikipedians, probably you don't so much care about these like 10 people that are out there kicking ass. What you care about is like this chunk of the curve right here. And so you want to talk about medians, which are going to fall like somewhere out in here instead of the mean that's getting pulled that way. There were a couple questions? Yeah.
So I was going to ask, why do we ignore the mode? But then this makes it.
Yeah, I mean, so you get weird things depending on what you're actually looking at. The mode can be interesting, but the mode also could just be totally random. The mode could show up anywhere in your distribution, so it is what it is. All right, and then the other way that we often show this sort of data is through the ever popular box plot. And so here is our movement times in box plot notation. And the main thing that you need to know about box and whisker diagrams is that you put the median on the line there. So this red line here is the median on each of these. And then the box itself is the what's called the interquartile range. It's the range between the first and third quartiles. And so this is the like box of stuff that you expect to be typical. And then the whiskers out here go out to what are called the inner the inner fences. And those are just going out one more standard deviation. So you have like your typical range, and then you have like your big range, and then outside the whiskers, you have like anything that you consider to be like a really crazy outlier. And so again, you know, median, mean, sometimes people plot their means on their box and whisker diagrams, 25th percentile, 75th percentile, interquartile range, maximum value, minimum value, unless you have crazy outliers, in which case you let them float outside the box and whisker diagram. And there's formalizations of this where like you usually put the people that are within 3 standard deviations inside the whiskers, and then outside of that you put circles for people, and then once you get another standard deviation away, you put hollow circles. And there's just all this like formality around how you communicate data using these different types of graphs. But the important thing for this class, I think, is that you just be like coherently able to read these things. So that's the median. This is normal. This is kind of the extended normal. Okay, cool, we good? I don't have to talk about box and whiskers anymore. Wonderful. All right, so here we're back to mean movement times for a moment. So these are our 2 normal conditions, and these were our 2 bubble conditions. What is weird about this graph or this chart? What would you expect to see on this chart that we do not see on this chart? I had to edit this chart to get rid of something so I could ask this question. There's a blank in the middle. That's weird. That's not what I edited. If you saw this chart in a scientific paper, what would you expect to see?
I just think it's weird that it's not going from like tall, like short.
It's inelegant. I agree with that. Although it is grouping by condition, which perhaps is logical. Yep.
I would put the 10s with the 10s and the 30s with the 30s.
Okay, so you could see grouping this in either way. You could see clustering the normal conditions and the bubble conditions, or clustering the 10 conditions and the 30 conditions. So there's some wackiness here in that we're displaying a like 2 by 2 dimensional space in like a insufficiently dimensional way. Yep.
Normally time is on the
Normally time is on the x-axis. We've been doing that today, but I don't think there's anything inherently xy about time. Yep.
Maybe it says movement time. What's it mean by movement time? From one thing to the next thing.
We are not heading in the right direction here, people. Yep. Okay, there's no frequency information. True. Not what we're going for. Everybody gets a guess. Yeah. Who hasn't taken a guess? All right, we're changing subjects here slightly, but what I'm talking about here is error bars, confidence intervals, things like that. So you expect when you see these sorts of graphs of like data to start talking about confidence intervals. And this is where we move strongly away from descriptive statistics and into inferential statistics. So the question that you're trying to answer with error bars and a confidence interval is, how confident are you that the thing that you sampled, the thing that you actually recorded out in the world, is representative of truth, is representative of like the underlying population? And so what you usually see here are something like a 95% confidence interval with error bars. And what we're telling you there is that this is the range in which we are 95% confident that if we were to go out and do this experiment with like thousands and thousands and thousands of more participants, the answer we would get would fall somewhere in that range, okay? And so you see things like 95% confidence intervals, you see 99% confidence intervals, and it's all just a matter of kind of how you're communicating your statistics and what you think is important about your statistics. So confidence interval, also called margin of error, are the sorts of things that you hear like on the news all the time, like somebody's leading the election polls by 10% plus or minus 3%. That is this like sampling error, where you're saying that if I went and I talked to way more people, I would be more sure that my sample is representative of the population, but this is how certain I am right now. And it all relates to sample size more than anything else. So if you have 1,000 people in your population and you want to sample it with 95% confidence, then you need to sample 278 people. Okay. If you want to get to 99% confidence, you would need to sample 906 people. And at that point, you're talking about like a big chunk of your population. An interesting thing, though, is that the way confidence intervals work, once the sample gets above, or once the population gets above a certain number, and that number is like tens of thousands, sample size starts to kind of fall out of the equation. And so sampling like 1,000 people is more or less just as good out of a population of 10 million as it is out of a population of 10,000. Like sampling 1,000 people is almost always enough for anything. Cool, sample size, exciting. My notes say that you only have to sample 500 people. So there you go, 500 people, enough. All right, back to our data. We've been talking in terms of just this, like, let's look at the graph and figure out kind of, what the data sort of feels like. But if we start digging into like the actual specifics of the data, here are our effects. So we varied some independent variables. We got some dependent variables. Here is what our data looks like. So for normal cursor versus bubble cursor at the small target size, we see that the bubble cursor is 31% faster. For normal versus bubble at the larger size, we see that it's 8% faster. We could also do this effect in the other dimension. So instead of varying normal versus bubble, we can look at just normal, target size. So the larger targets are 35% faster regardless of which cursor condition you're in. And the target size for the normal cursor, 35% faster. Target size, larger targets for the bubble cursor, 11% faster. So anyway, we're just looking at this 2x2 space, and so we get 4 results, and those are the 4 results. What does that tell us at this point about our 2 cursors? How confident can we be that our bubble cursor is superior? It's looking good still, right? What else is coming out of our data here, though? In addition to the fact that the bubble cursor seems superior and, not surprisingly, large targets seem superior, what else are we learning?
The effect of the bubble cursor, or how much improvement it can give increases as your target size increases?
Yeah, so it appears, based on this like preliminary view of the data, that probably the bubble cursor has a much more differential effect at smaller target sizes, right? Whereas at the bigger targets, we would be able to hit them more easily with the normal cursor, and the bubble cursor is not helping you as much. So we'll keep digging into that as we go through here. And then the effect size on errors is that normal versus bubble cursor at the small targets, there's 1,000% fewer errors, and normal versus bubble at the larger target, there's 460% fewer errors. We're still heading towards the same conclusion that there's some interaction effect here, though. Yep.
Can you go back to the last slide?
I can.
For comparing like the larger versus smaller targets, is that the average or like the minimum of the 2?
I believe it's probably the median, actually. So I think we're looking at the medians here, although maybe it's the means, but it's definitely not the minimums. It's something like some sort of middle descriptive stat. Central tendency descriptive stat, I should more properly say. All right, so digging into this interaction effects thing, is there a relationship between one independent variable and dependent variable that depends on the level of another independent variable? And so here's an example from Martin. Here we have just a chart of like ability to solve problems. So lower is better. It's how long it takes you to solve a problem. And this is with a leader or without a leader. So people with a leader, hooray, are faster at solving problems, and without a leader are slower. If there were no interaction between group size and this leadership variable, this is roughly what we would expect the data to look like. So we would see the same differences in how long it takes you to solve the problem on the with leader condition and the without leader condition. So that is this delta here will be consistent across all of these. And this delta here will be consistent across all of them. So, having the leader or not having the leader doesn't change how effective your group size is. And having different group sizes, it doesn't matter whether or not there's a leader, okay? So that's no interaction effect. This is something that looks more like real data that has an interaction effect. So here we see that having the leader isn't as big or having the leader decreases the difference caused to your effectiveness by the size of your group. So having a bigger group makes you tend to have more trouble solving problems unless you have a strong leader, in which case they get compacted back down. So interaction effects, that's all you need to know about that. The interaction effects of our bubble cursor seem to be pretty strong, as we already indicated. And it shows up most strongly here on the times. So it appears that for the larger target size, the two conditions are much more similar. And for the smaller target size, they're much more different. Make sense? All right. A little bit more about inferential statistics. Just remember that the key point here is that you're taking some small sample. You are observing something minor about the world and then projecting that into some major claim about how the world works. And so you want to be relatively confident that you're doing that in a sane way. And you have to kind of keep track of where your sample came from and does it really represent the population and how many people do you need to sample and all of those bits of the problem. So getting into this notion of are your results meaningful, I had you do a reading for this Thursday that's basically testing is bullshit. Now I'm going to talk to you about significance testing for like 10 minutes. And the reason for that is that this is still what you need to know if you're working in the HCI world, because while Bayesian statistics are sort of slowly taking over the world, they haven't gotten to HCI yet. And so we're still very much in like t-test, ANOVA, Mann-Whitney land in HCI. And eventually we'll move to other things, but for now you need to be aware of this. And so the fundamental thing we're doing is hypothesis testing, where you have some hypothesis that manipulation of the independent variable will have an effect on the dependent variable. You have what's called the null hypothesis, which is just the no effect hypothesis. Manipulation of the independent variable does nothing to the dependent variable. And in kind of classical significance statistics, you start with the assumption that the null hypothesis is true, and then you look for statistical evidence to disprove the null hypothesis and to prove your hypothesis. The classic way to represent that value is a p-value. And so in HCI, we use p less than 0.05 as our kind of standard for significance, which is just saying that there is a 5% chance that the thing that the result that you have found is due to sampling error rather than like a real effect in the underlying population. So there's a 5% chance that, if you were to do this again, you would see a very different result, that sort of thing. The tests to get us to these things are t-test, students t-test, correlation, ANOVA, MANOVA, which has the best name, I think. And all these different kind of statistical tools for starting to parse out how things relate to each other. So students t-test. Students t-test has a fun backstory. Does anybody know like where students t-test comes from? Who came up with students t-test? It's more interesting than the actual test, so we'll linger on it for a minute. There's a guy whose name was not student. He was writing under an alias, and he was basically hired by Guinness to invent statistics. Guinness had quality control issues, and so they brought in a mathematician to like sit down and figure out how you could predict the like loss rate on batches of Guinness. And Guinness recognized that the work that this dude was doing was very significant to kind of the world at large, so they let him publish his work, but they made him pick up a pseudonym so that people wouldn't be able to trace it back to Guinness that was doing all this work. So there you go. Guinness also like If you're not aware, Guinness Book of World Records and Guinness the brewery, same thing, which isn't obvious if you don't know that to be true. But it all comes from like Guinness having this like rich background and having like partially invented statistics. Anyway, so t-test is comparing the means of two groups and seeing if there's a meaningful difference between the means. So you're just saying, is condition 1 and condition 2 statistically significantly different at some confidence interval? It assumes that the samples are normally distributed, which is often true, although you need to kind of look at your numbers and see if it's kind of bell-shaped-ish, and if not, maybe you should go with ANOVA. Most importantly, and what people most screw up with t-test is that you have to assume that individual observations in the sample are independent, which is rarely true. So if that doesn't make sense to you, go take like a real stats class and don't listen to like a user experience designer telling you about stats. But it's an interesting problem. ANOVA is what we actually always run on this sort of data. So ANOVA, your typical UX dude knows how to like fire up R enough to like get an ANOVA result. And so this is a single factor analysis variance sort of technique. We often just use two-way ANOVA to take these 2x2 conditionals and try to find significance levels between them. There's repeated measures when you have more than one observation per subject. So when you're doing like within subject design, this is what you're supposed to use. ANOVA, which is all about multivariate spaces. And anyway, ANOVA tests tell you whether the means differ, but they don't actually spit out like the answer to which two groups gave you the significant difference. So then you have to go and do like pairwise t-testing. So anyway, if we wanted to do ANOVA on our bubble cursor thing, which ANOVA variant would we use? Which? Everybody get inspired by statistics? I swear to God, after the midterm, we're going back to things that are not statistics, and it'll be so wonderful. Anybody? All right, you just use two-way because you got a 2x2 space. You use a two-way ANOVA, and here you can start pulling out your significance levels for these things. And so is there an effect for cursor size? Yes, it's like super strong. It's absolutely, there's some effect for cursor size. Is there an effect for size of the target? Yes, absolutely. Is there an interaction between cursor size and size of the target? Yes, absolutely. And so these are the things that ANOVA spits out to you, and you say, hooray, and they go straight into your Chi paper. And then you don't think anymore about whether it actually makes sense. And that's why statistics in the HCI community are in terrible shape right now. But you could imagine now taking the next step and like digging into like, does all this really make sense? Is there some underlying fact about humanity or about your sample that leads to this result? And how could you prove it again? That sort of thing. A few more ANOVA values. Yeah, so these are the error values, the previous ones for time. So is there a statistically significant effect for cursor size and an interaction in terms of errors? Yes, not surprising. How about errors in the bubble cursor case only, though? So the error rate between the small targets and the big targets. If we do that and we pop it into ANOVA, we get a p-value of 0.92, which is not super encouraging in terms of there being some meaningful relationship there. But what does it ultimately really mean? So if we have a p-value greater than our 95% confidence interval that we decided up front that we're going to go with, we know that we can't safely infer that this would be true of the underlying population. So we know that it's not statistically significant at this 5% level. But does it really ultimately mean that the two conditions are equivalent? Does it mean that the big cursor, or the big targets and the small targets are the same in the bubble cursor case? No, not necessarily, right? We did observe some difference. Like there was some drift between the means and the medians, and maybe there is really something going on there, but there's no way we can be confident that those differences weren't due to chance. So that means that we can't infer that the underlying population has this meaningful difference from our sample. But if we were to go do another 10,000 samples, we wouldn't be shocked if we found some effect there, right? Totally possible. All right, and then in conclusion, you need to kind of start drawing answers from your data. And so what's the scope of the finding? You know, do you think that your answers make sense within your experimental context? You know, are they internally valid? And then does the experiment reflect real use? Is it externally valid? And on this notion of like, you know, quantitative evaluations, the point here is that we're doing repeatable, reliable evaluations. We want to control things properly. I will go back to this notion that I keep saying, which is that while this stuff is very super important for research, and it's what like HCI professors do, and it's what HCI grad students do, it is a very small part of what like HCI practitioners do. So I never, ever, ever sit around like generating means and medians and modes and things. Like I run qualitative studies, and most UX people run qualitative studies, and it's usually enough. And the reason is this: it may be really hard, even from a like really awesome, statistically significant quantitative result, to decide, is that going to have some impact in the real world? So say you did your, a menu selection test, and you found a p less than 0.000001 strong, statistically significant difference between two menu designs, but the actual like concrete time difference was 5/100ths of a second, something like that. Will that have any like meaningful impact on actual use? No, it doesn't matter. Like it's really easy to find statistically significant differences in a user interface that have absolutely no practical value, no practical meaning. And so a big part of what you have to do as like the HCI person doing the quant work is to be less the like data analyst and more the like experimental designer who says, does this matter? Are we getting something that we can use to improve our design? And how do we go from this data to a better design? That's the most important things in all of this. Make sense? All right, we're going to digress for the rest of this talk because I'm not interested in talking about statistics anymore. So step one, midterm, Thursday, 75-minute exam, be here on time. Tell your friends who are in this class that they should probably come on Thursday. I will be very mad at the people that show up on the following Tuesday and are like, midterm? That won't end well for them. So be here on time on Thursday. Covers everything up to today's lecture. Closed book, no notes, no tech, no Google Glasses, no bullshit. For now, we're gonna do it all in here. I'm not totally sure we all fit in here. So we may also reserve another room for overflow. So if you show up and like all the seats are taken, hopefully we'll have a backup plan. Tuesday is going to be a review session. So the GSIs are going to run the show in here on Tuesday, answer all your questions. They were talking about doing something fun and wacky and useful. So hopefully that will be cool on Tuesday. I'll also be around to answer any questions you have. If you've got a DSP letter on file, I'll be in touch today. I'll be sending emails out to you guys. So no big deal. What else we got? So things that you should be aware of, like things that are fair game, everything from lecture, everything from readings, and the things that I think you should have learned from doing your assignments. So that's both the group assignments and the individual design assignments and the programming assignments. So anything that I think you should have learned from that process, totally fair game. All of the lecture slides are on the website. Many of the videos of the lectures are on the website, though not all of them. So if you go to the course website, you can check out all of the material you need to study. Lo-fi video prototype is due tomorrow. Lots of you guys are starting these things way too late. Like get on these earlier in the week. These are not gonna go away. Like my assignments are gonna keep coming every week, basically. And these group assignments are just like boom, 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 step, step, step. And they're not the sorts of things that you can do in like 5 hours on Friday. Like spread it out over the week. And like think about these things a little bit more carefully because the GSIs are going to start getting more and more critical of you on the grading. I think that the contextual inquiry grades kind of surprised a few groups because suddenly like we're paying a little bit more attention. But like be aware like there's a difference in quality between the groups right now, and those differences in qualities are going to be reflected in the grades. So shape up. Some of you guys need to work on group dynamics. There are a few groups that the GSIs have flagged as kind of potentially struggling to get their kind of collaboration up and running. If you hear from a GSI, so the GSIs are kind of taking a few groups off to the side and asking to meet one-on-one or to do some extra planning for how you're going to collaborate. Please cooperate with the GSIs. I'll be paying attention to that whole process and seeing how that goes. And also, improve your time management skills, kids. Shape up. This isn't that hard. Like, don't do all this stuff at 11 p.m. on Friday. And if I have one more person submit at 11:59 on an assignment and then complain that it didn't finish submitting until midnight, I'm going to be furious. I'm tired of that. Like, get this stuff done a little bit earlier. All right, team dynamics. As I said, the GSIs are reaching out to some groups for extra mentoring. Please be responsive. Please help. I am paying attention. It will affect your group grades. I really don't believe the groups that are coming back and telling me that they can't find a time to meet. Bullshit. Like, find a time to meet. Even if it's just on Skype or Google Hangouts or whatever, like, pick a couple hours during the week where you can consistently meet. If it's at 8 p.m. on Friday, suck it up. It's what you have to do. But, like, find a time to get together and, like, really put your heads together and work on these things. And then next week, we'll have a very short online Google form sort of thing to fill out to evaluate all of your group members and the group dynamics and tell me how things are going. It's in lieu of reading assignments next week. We'll just have this like one thing you can fill out anytime next week to tell us how your group is doing. Cool? Questions on the project, groups, rebellion? Not against me. You can't rebel against me. I have an iron fist. But if you were rebelling against the rest of your group, let me know. Cool? All right, the rest of the class, we're going to unwind a little bit with the IPA 2 Hall of Interesting. So again, to remind you of the rules of this, the criteria for inclusion in the Hall of Interesting is not necessarily that your assignment is good. It's that your assignment is in some way curious to me. I will say that on IPA 2, there were way more of these than I had time here to actually include. The results on, I was really pleased with IPA 2 just from a like instructional design perspective, because the like variety of responses that we got were really, really weird and interesting. So I'm gonna walk you through just a few fun, exciting IPA 2 assignments.
Hello world, I'm here to introduce you to my XKCD comic viewer that also fetches Flickr images and reads the title to you. I'm calling it not quite Microsoft.
So here I have the XKCD comic. I can click next or previous to fetch a prior one, next to serve the next one. I can click the Flickr button to search Flickr and return the first image. And I can click this play button to read the title to you.
Vacuum. Friendship, friendship, friendship.
Thanks.
All right, so that's interesting in two ways. One, it's very representative of kind of a class of results that you guys submitted. So it's just like show the comic, have a button to toggle between Flickr, have a next and back. And then why not? Let's have it talk. Wildly technically difficult. Congratulations to the person who did this. Like there was real work involved in making that happen. What do you think of the user experience there? Like, do you need the thing to read the title to you? It doesn't hurt anything, right? It's surely at least as fun as it not being there. So I'm all for it. Number 2.
This is FlixKCD or however you want to pronounce it. Basically, it's a web app that starts by pulling up a random XKCD comic, and it looks at the first word in the title, in this case December, and searches Flickr for images with that tag, and it displays 3 of the results on the right side of the screen. So you can navigate by pressing the previous and next buttons, and it just goes in order of whenever they were added to XKCD. And you can also click on random, and it'll take you to a random comic, and it knows how many total comics there are. It checks when you open the app using the XKCD API. And if you have a favorite one, I don't know, I'm just putting in a random number, you can search for specific ones, and I'll open that one. And that is about all.
Okay, a couple interesting things there. Some of you were very clever and took advantage of the fact that I forgot to specify that this should be on a phone. And so you used the ginormous Canoma desktop simulator, which made the interaction design an awful lot easier. Crafty you, shame on me. You won't fool me again with that one. But we did start getting some of these interesting solutions where there's just like, here's a bunch of Flickr images next to the XKCD comic. That's cool. The search thing is neat. That was non-trivial to implement. Snazzy, I like it. All right, the next kind of evolution of these assignments was moving towards putting the Flickr image in a more designy place than just toggling between the two. So here's one.
Welcome to the XKCD app. Here is the home screen with the title of the comic, the Flickr image that's affiliated with the title, the comic itself, and the navigation buttons in the bottom that include previous, random, and next. If you select the random button, it takes you to a random comic, and from here we can navigate to the previous, or we can then go to the next. We can also select random again, and it'll take us to a brand new random comic. Thank you for watching the demonstration, and I hope you enjoy the app.
All right, so that's interesting. Like we've got the Flickr image kind of integrated in a way that's something more compelling than just a toggle. I dig it. The further evolution of that was we had a few solutions that did something like this.
Hi, this is Diane, and I'm here to talk about my app that integrates XKCD comics and Flickr photos. I creatively named it XKCD and Flickr. So I'll start with how I push the task, and then I'll describe some of the elements in more detail. I wanted to display the picture in a way that enhanced but didn't interfere with the browsing of the XKCD comics. So I decided to use the picture as the background of the header. Since comic browsing is the main purpose of the app, the comic occupies the majority of the screen space. Okay, so here we see the first screen. The screen starts with the comic of the day. To navigate, we have 3 buttons on the bottom. This one goes to the next comic. This one goes to the previous. And this one to a random comic. The buttons are simple and intuitive. As you can see, the picture of the header updates with the comics with the relevant picture from Flickr. There's the comic title here, the comic itself, and the descriptive text under it. For the extra credit features, I implemented a random button, integrated the text in a non-destructive manner, and also paid attention to design and how the user can get the most out of an XKCD browsing app. And that's pretty much it. So thanks for listening.
So that one, I like the elegance of the displaying the Flickr image behind the header. Very subtle, but very much in the spirit of the assignment, I think, where like it's there and it's adding something to the user experience, but it's not like just a button to toggle between the two. So that's cool. This one is in the list only because I literally don't understand how it works.
So what we have here is an app that displays XKCD comics. Let me just walk you through it. When you open the app, it defaults to the most recently released comic. So what we see here is a comic titled Vacuum that was released today, February 13th, 2015. You can also see a background image from Flickr that's related to the words in the comic's title, so vacuum here and vacuum there. You can navigate to different comics by swiping. Swipe right to bring up the comic that appeared chronologically before the current comic, so February 11th. This comic was released 2 days ago. Swipe left to get the comic that appeared chronologically after. Note that swiping left on today's comic won't do anything since there haven't been any new comics released yet. If you want to select a random comic, just swipe up and it'll pull up a comic that was released at any time in XKCD's existence, so November 28th, 2014. And we can pick another random comic too. And if you want to return to the comic you were previously viewing, swipe down. And you can keep doing this until you end up at the comic you originally started at. Well, that about covers it. Thanks for watching.
All right, so 2 interesting things there. One, we start to head into like a more interesting interaction design. So thinking hard about like, how do I navigate between the comics and how do I invoke gestures to do different things? It's interesting. I've looked at the code of this assignment and I still don't understand how this works with the like translucent XKCD comic. I'm calling shenanigans on this somehow, but I don't know how this video came to be, but I like it. So there it is. Something interesting happened there. So welcome to the Hall of Interesting. All right, next we move into 1, interesting interaction design, and 2, grandiose claims. Anybody that in their video claimed this to be the most amazing thing ever gets extra interesting points from me.
Hi, this is Juan Pinzón, and today I'm going to show you my application, Comic Life. Comic Life has navigation buttons at the top, so you can go back and forward through the comics. If the comic doesn't fit on the screen, you can scroll on the screen to see the whole comic. So which is really amazing because some comics are really huge, so you can scroll and see the whole comic. Also, the application has an amazing sliding menu that show the feature of the comic. So first, they show a picture that comes from Flickr and show information like description, number, and year. Each time I change the comic, the information is updated automatically on the featured sliding menu. Also, the application has a random button that generates random comics. So you can use it to change the comic and go to the comics of XKCD. And also, each time you change the comic, the information of the comic is updated on the sliding menu, which is really amazing, you know? User-friendly. I hope you enjoy my application. Thank you.
So that is both one of my favorite apps and one of my favorite videos. I like the drawer for the Flickr thing. It's a way to kind of get it in there in a non-obvious way. And it's a good example of like finding something in the Canoma stack that was useful to you, which the students that wanted to do extra work to be lazy did. My applause to everybody that like went out and found the built-in Canoma things that could help you on the path here. Anyway, that's a favorite of mine. And the other thing that's interesting here is we're starting to talk about how we deal with large comics. So how do we pan around big comics? How do we zoom? Things like that. Some people did better than others, but that's starting to head in that direction of like not just shrinking the comic down to a tiny size. All right, next.
Hello everyone, welcome to my app, Just One Comic, which by the way is what we think of ourselves. Anyways, this app is a XKCD browser which pulls together photos from Flickr 2 based on the title of the XKCD comic. First, we have a few instructions which tell the user how he's supposed to interact with the app. We will swipe from right to left to go through the instructions. As you can notice, we have an indicator at the bottom which tells you which instruction page you're on. Now let's move on to the actual app. The app has 2 rows. The row on the top corresponds to the XKCD comic, the row at the bottom corresponds to the Flickr photo based on the title of the XKCD comic. So now to go on to the next comic, we just move from left to right or swipe from left to right, like so. And both the pictures get updated, and we can do this again. Now to move back to the previous picture, we can go from right to left. And as you can notice, the comic and the photo are quite small, so one might actually want to make the comic enlarge the comic, in which case he has to swipe from the top to the bottom. As you can see, it becomes full screen, and to swipe it back up, or to go to the previous screen, you swipe it back from the bottom to the top, and you can see the 2-row view. Similarly, if you want to enlarge the Flickr photo, you swipe from the bottom to the top, and you can again swipe from left to right, and it will go into the next Flickr photo, and swipe from the top to the bottom to shrink it down, and you have the corresponding XKCD comic too. This was just one more comic. Hope you enjoyed it.
All right, so that one is, there's much to be interesting about. The first run experience is quite a thing. So going in there and having instructions on how to use the app and like teaching you how to use the app, there's an argument for it and there's an argument against it. But at least it's clear. And on these things where you're hiding gestures in the interface, I think it's worth doing. That makes a lot of sense to me. And then this also, one, does the like swipe left, swipe right for moving between comics, and then does this like zoom thing for getting both of the images on the screen at once, and then allowing you to selectively look at the two. Clever, I like it. What's next? All right, now we're starting to get into like serious business.
Title. If it's like hard to read, you can zoom in with like pinch to zoom. You can scroll, just to make it easier to read. You can like even rotate them. Yeah. Sorry, I'm using my trackpad to do this. But yeah, that's like with a multi-touch library. Going left, like will take you to the previous comics. Right, will take you to the next comics until you wrap over and get the very first comic. So pressing the random button takes you to a random comic, which is like an extra credit point, I guess. And pressing the flicker button will take you to will bring up like an image, just like a random image using like the search title. The title to search for related images, and then just display that, and then clicking like the stick figure, XKCD guy will take you back to the comic. Yeah, that's all.
All right, so there we had somebody that figured out how to use the multi-touch library. Good on you. You found pinch to zoom and rotate and spin and all those things. And then actually why I put this one on here more than anything is I like the header icons, which by the way is also built into Kinoma and a few of you found. But like moving towards something that actually kind of looks like an app. Admittedly, this one looks like an app from 3 years ago instead of an app from today because we've kind of moved away from header icons and towards a flatter design. But it looks like a mobile app in a way that many of the solutions just kind of look like stuff on a screen. So definitely a step in the right direction there. I dig it.
This is my XKCD viewer. As you can see, when browsing individual comics, you can pan about the comic with one finger. You can pinch to zoom with 2 fingers. And you can slide between comics by swiping. If you do a long press, similar to the website, it will bring up the alt text. This maintains the sort of Easter egg aspect of the alt text in that it requires some discovery to find the secret. In addition, I've thrown in the Flickr image underneath the alt text for good measure. You can also rotate the screen, and the comic viewer works as expected. And that's about it. Thank you.
All right, that one wins the award for most passive-aggressive inclusion of the Flickr image. This is where I put the Flickr image because somebody made me. I dig it. And then they also found the Kinoma slide viewer. So the slide viewer is doing the pan and pinch to zoom and transitions between various comics. So very clever to have dug that out of really the boneyard that we haven't used the slide viewer for anything in like 5 years. So very cool. And then, so what I want you guys to get about that one is that it's starting to feel more real because somebody like, and in this case, admittedly, it wasn't a student, it was somebody at Kinoma, thought about those transitions and thought about the like interaction design around the edges and how the thing should bounce and spring and just how the whole thing should feel. It really kind of pops as a more rich interaction design than the kind of ones that just kind of statically pan around and don't have a whole lot of life to them. All right, I've only got one more of these. This is the person that I think you should most want to be in your group.
Hi, this is the second programming assignment for CS160, User Interface and Design. So for this one, we were supposed to use the XKCD API to parse JSON and get the appropriate images and titles, as well as relevant Flickr images based on that title. What I did to make this more user interface friendly was make the Flickr images black and white and slightly blurred with Gaussian blur. So like the comic would be the focus and the image would be more in the background. And you could slide it, I guess, horizontally to see the image itself if you're interested. And also sometimes the comic itself is cut off, so you can slide it up and down to view the entire comic without covering the buttons. The buttons have images associated with them, kind of playing around with the comic theme, so they look kind of like drawn out by pencil. Also, I made transitions, and also because we're using API calls, if the user doesn't have internet, they deserve to know that you don't have internet, and that's why you can't get the comics right now. So I give them a message to let them know. And once they do have internet again, they should be able to get the comics perfectly and be on their happy way. I also implemented transitions for previous, next, and random buttons to give a sense of the direction the comic is going towards. And that's all. Thanks.
That's just a badass solution to the problem. I just really like that one. That one I will say I like. That's not just interesting, that's good. So lots of Flickr images in there, lots of cool transitions, really thought about the kind of user experience in terms of what happens when the internet's down and how should this thing look and feel as you move between things. Very cool solution to the problem. Congratulations on that one. So what else should I talk about today? We've got like 5 minutes left and I've got no more material. If you have any questions on the midterm, let me know. I'll hang out up here, and good luck studying. Like, go and hit the lectures and review the readings and skim everything. And like, don't be surprised when there are some kind of small details on this exam. It probably won't be super technical, but it will be pretty detail oriented. So good luck. Let me stop the webcast here real quick.